Welcome students to the series of lecture on LangGraph, and in the series of lecture of LangGraph, we are again in a series of lecture of memory in LangGraph. In the last session, uh, we introduced the concept of memory in LangGraph. Definitely, we briefly talked about memory in LangGraph in the previous session of persistence. That's fine, but actually, the last session was the first session where we really discussed about, or where we really introduced in detail the concept of memory in LangGraph. So first of all, let's recap what are the key points that we have established in the last session. The first and the most important one is LLMs are memoryless. It doesn't have memory, whatever kind of LLM it has. So every call that you make to LLM, every invocation to the LLM, it is memoryless. It doesn't remember what happened in the past, what was a conversation, who was the user, nothing. Similarly, LangGraph without persistence is also memoryless. Okay, so we have to introduce the concept of memory, and we have to introduce two concepts of memory. And we discussed that there are two different kinds of memory. The first is the short-term memory. The short-term memory is related to the conversation memory. The conversational memory is short-term memory, and long-term memory is the another type of memory which is related to the user identity, user information. That is what we have discussed in the last session. And we also seen in practice through the code that actually LLM does not have memory, or LangGraph does not have memory until unless you use the component of persistence. Okay, so what we did in the last session, we initiated a conversation with LLM. I said, my name is Saurabh. LLM responded, and then I asked, what is my name? And LLM responded, I don't know your name. That's what has happened. Okay. In today's session, we'll try to understand a very simple trick, a very simple trick that will start making you feel that yes, LLM has memory. And that trick is the trick of context window. Actually, LLM doesn't have memory, but the way we will interact with LLM is that we'll try to change the context as per our requirement, as per our need, and through this trick, we'll make LLM respond in a way that it feels that it has a memory. So let's understand this trick. And this trick is very simple, very straightforward. But understand this simple trick, only this simple trick is taken by LangGraph, and they have used it to implement short-term memory and long-term memory. That's it. And the trick is related to the context window. Okay, so I'll jump directly into the code and explain you first what is this trick and how LangGraph has used this trick of context window to implement the memory. So let's jump into the code. Okay, so in the last session, we ran these code and we proved that, hey, LLM is memoryless. For example, let's understand. I'm sending a message. Hi, my name is Saurabh. This is the output. Hello, Saurabh. It's nice to meet you, blah, blah, blah. What is my name? And the response is, I don't have any information about your name. So it means that LLM are memoryless. It cannot remember the past conversation. Now, what is the trick? The trick is the trick of the context window. Let's understand. Again, I'm not using LangGraph. I'm just trying to invoke the LLM with LangChain, with a very simple library of LangChain. Nothing fancy. So see what's happening. This is my message variable. And I'm saying there is this new message, which is, hi, my name is Saurabh. Perfect. What I'm doing, I'm updating my blank variable messages with append, as in I'm concatenating the variable message with the new message. Messages append new message. Let's see what it is. It says, okay, hi, my name is Saurabh. And this section, anything inside these two bracket is the context window. What it is? Context window. So this is your context window. And in this context window, I'm sending my messages variable, which has the information about my name. Perfect. Let's see. Okay. LLM got invoked. and it responded. So this is the respond. Nice to meet you, Saurabh. Is there something I can help you with? Blah, blah, blah. New message. Again, new message is what is my name? And I'm appending or concatenating to the variable, which is messages, which already have the information of, hi, my name is Saurabh. Append it with a new message that is, what is my name? Or you can say new message to, new message to, see, new message to. And this is the new message which got appended in a variable messages which had earlier conversation. Let's see what this messages look like. This messages has all the conversation. Hi, my name is Saurabh, and what is my name? So when you're throwing the messages variable inside this context window, the area between these two brackets is your context window. It has all the required information about my name because I concatenated all the previous messages. And you should understand that the respond is now going to change and it is responding my name as it is. And the reason is very simple. It is a very simple trick. You have provided the information in the context window. Yes, LLM are memoryless. But you are saying, okay, you are memoryless. We understand that. But whenever we will communicate with you, in your context window, I'll provide all the information for which I need the response. That's it. Very simple trick, very straightforward trick. But this is what is being used by LangGraph to implement memory. That's it. What they are doing, they are not going to implement memory in large language model. They cannot. Large language model is a different entity. LangGraph is a different entity. If I'm saying LLM cannot have memory, it cannot have memory. But this simple trick of appending the context that you are communicating with LLM, you're providing all the requisite information there. And through this, it gives a sense of that LLM has memory, but it doesn't have memory. Quite a very stupid trick, but this is the trick which is being used in any framework, whether it is LangGraph or any other framework on the world, where you get a feel that LLM has memory. Okay, this is the trick, nothing. So how LangGraph is implementing the memory with the help of context window. Okay, so let's see if I'm using LangGraph. So I have incorporated all the requisite library. I have imported all the requisite classes of the LangGraph, which is state graph, messages state, and start. Now, I'm not creating any state dictionary. I'm using the default basic message state capability of LangGraph. So yes, I'm using state. Okay. So this is my first node. This is my edges. And this is my graph, a very simple graph start, well, where I'll send the message to the LangGraph and it will invoke the model. That invoke model is my node, which will invoke the large language model and it will send me the response. And we tested in the last session that if I invoke this graph, then it will respond to my content. That is, my name is Saurav with hello Saurav. It is pleasure to meet you. But if I invoke this graph with another question, what is my name? Then it will respond that I don't have information about your name. So even LangGraph is memoryless, which we proved in the last session. We said in the last session that with the help of three concept of persistence, which is state, checkpointers, and thread ID, we will implement short-term memory. I'm repeating. So with the help of three concept of persistence, that is checkpointer, thread ID, and state, we will implement short-term memory in LangGraph. That's what we discussed in the last session. Okay, so let's see how it will work. I'm restarting the kernel. Perfect. So I'm running this cell to import the important libraries and class. I'm defining the node. I'm defining the edges. Now let's wait. I'll not compile my graph. I'll not compile my graph. The reason is we have to use checkpointers. We have to use checkpointers. Now, whenever I'll compile my graph, I'll pass checkpointer. Perfect. How will pass it? I'll use a class InmemorySaver. InmemorySaver. With the help of InmemorySaver, I'll create an object of InmemorySaver class and I'll pass that inside the checkpointer. We'll understand what is InmemorySaver, what is checkpointer, everything. So this is the basic implementation of checkpointer. Okay, I implemented it. I already implemented the state. Perfect. And even when I'm creating my state graph object, I'm passing the state. So I've implemented the state. I have implemented the checkpointer. The third component was thread ID. So understand, I'm saying configurable. I'm passing thread ID as user1 and user2. So config1 is for user1 and config2 is for user2. That's it. So the third implementation is of thread ID. Perfect. Now let's see what happens. Now I'm invoking my graph with the content that, hi, my name is Saurabh, but I'm sending the information of thread ID through the variable config1. And if I'm saying config1, then the thread ID is for user1. So user1 has a name that is Saurabh. So that's why, sorry, somehow. Okay, we haven't defined the LLM. So let's define the LLM. So we defined the LLM. Let's run the graph again. Perfect. We'll compile it here. Config 1, and for config 1, which is for thread ID or user 1, see what is the response. The response is nice to meet you, Saurabh. Now, if I ask, now see, if I ask what is my name for user ID 2, it will again say that I don't have any information. But if I will ask for config 1, then actually it will respond with the correct name and see, and it is responding your name is Saurabh. The reason is, with the help of thread ID, with the help of checkpointer, and with the help of state, what I'm doing, I'm combining all the information and sending it through the context window. That's what I'm doing here. When I'm saying graph.invoke, I'm giving the information about what? About user1 through config1. First of all, so I'm providing the information about user1 through the config1 information in the graph.invoke. I'm repeating, I'm sending the information to LLM through config1 about user1. So whenever I'll hit the LLM through config1, it is looking for the information related to user1. That is the most important point. But how it is implementing it? It is implementing it through the help of checkpointer. Understand what is a checkpointer? Checkpointer is the snapshot of your state at every node or every step. So basically, state. What is state? State is the information about the node, information about your graph, information about your workflow. And what checkpointer does, it saves a snapshot. It saves a snapshot at different nodes. So it is saving it. Now, the checkpointers are the snapshot of the state. But how it is getting saved? It is getting saved in the RAM with the help of InmemorySaver class. InmemorySaver class has four responsibility. It has four responsibility. Let's see. Let's go to our notes. So InmemorySaver class, if you read the document of InmemorySaver class, you will understand InmemorySaver has four responsibility. It has function like put function, get function, delete function, update function. If you open the class, you will see these functions there. So InmemorySaver has a responsibility to save the snapshot, to retrieve the snapshot, update the snapshot, and delete the snapshot. Okay. What is snapshot? Snapshot is the checkpointers. Snapshot are the checkpointers. How you implemented the snapshot with the help of checkpointer. What is the state? State is the information about your workflow at every step. What is a checkpointer? Checkpointer is the snapshot of the state at every step. How you save this checkpointer? With the help of InmemorySaver class. How you retrieve the checkpointer? With the help of InmemorySaver class. Every checkpointer, which is the snapshot, is related to a particular unique thread ID. The thread ID could be user 1, user 2, user 3. You can think of it like InmemorySaver class is saving the checkpointer, which is the snapshot of your state for a particular thread ID continuously. And it also helps to retrieve the snapshot with the help of thread ID. So this is how we implement a short-term memory in the land graph. And state checkpointer thread ID and in-memory saver class implement the short-term memory through RAM. So it is not in a durable system. So it is a short-term memory, but in RAM. Okay. So you understand that you can pass the information in the context window, but there is a limit to the context window. Currently, we are using Llama 3.1 model. The context window for Llama is 8K, and the the better model has 128K, which means that if it is 8K, if you're using Llama 3.1 model, then you can send a consolidated information of approximately 15 pages. If it is 128K, as in the higher model, then you can share the context of 180 to 190 pages. Gemini 1.5 is 1 million. If it is OpenAI ChatGPT 4 model, then it is 128K. That is the context window. Again, it is somewhere around 180 to 190 page. If it is cloud, then it is 200K. That is around 300 pages. If it is Mistral large 2, then it is 128K. So you can understand that in the context window, you can share a lot of information, but you have to manage it properly because you can only share the relevant information and the needed information. We'll study about this in the upcoming session. So in this session, what we have covered in this session, we have seen that in LangGraph, we can implement the short-term memory in RAM or short-term memory through RAM with the help of in-memory class, checkpointer, thread ID, and state. Okay, I'll pause here. In the next session, we'll understand that what is the problem of the short-term memory with RAM persistence. And to and in the next session, we'll understand that what is the problem of short-term memory with RAM persistence. And we'll also see that how we can implement short-term memory with a durable persistence. That we'll study in the next session. Okay, with that, I'll pause here. Thank you. Have a nice day.